-4, -1. We have O is -3, 1. So that is my O. And my last one is G is 2, 1. So it says we have to put an H down. That makes it H-O-G. So that means OG is maintained. The only thing we can move is the D. So the only place we can put it is up here to maintain that order. So we can put it up here, and we'll see that it looks like the exact same angles. So that's going to be my H, which is -4, 1, 2, 3. -4, 3, which would have been A. Majority of us had A. A couple for the other one. What other spot do you think it could be?
Yeah, because I just realized it's the way the...
Were you going to put it over here?
Yeah, because
Yeah.
it's like I thought you could do that.
It can't go over here. How do I know where actually it's kind of... So we only can move D, right? So we'll try a couple different places with D to match it up. The easiest way is, if it's just D, just shoot it straight across this line. Go straight up is going to be the easiest way.
So just count, just counting how far it is
Yep.
away from...
Yep, kind of how far away it is, and then go 2 up here. Let's say I needed to move G. I would just move it straight over here. All right. If I needed to move O, I would go straight down here. Yeah. Oh, so see this line here? That's kind of what we're kind of flipping it across. So if I'm talking about moving D, I'm talking about moving D, right? If I want to preserve this angle, I'm going to go straight across this line here, this fake line that's created by this. If I need to move G, I would flip it straight across over here and I'll kind of preserve it. Kind of a mirror image. I'm trying to create a mirror image. That's a great way to put it. Thank you. A mirror image. I'm trying to create a mirror image. So if I needed to move O, the only way to create a mirror image is to, actually, you kind of see what I'm, to create the mirror image, I'd have to flip it across here. So this is just that mirror image. We're just trying to create a mirror image. Okay, does that make it a little clearer? That's why I did 2 in a row, because it's hard to picture it. Maybe we'll do another bell work or just practice these. Yeah.
Oh, no,
You're good?
I just kind of
Okay.
I realized after I put it in, I realized that it was the wrong answer.
Okay, good. So let's make sure we are wasting a bunch of time when we come in here. I'm going to keep reducing the time, because if I'm giving you too much time to work on your bell work, then that's my fault. And if we come in and we're just talking the whole time, that means I'm giving you too much time. Also, make sure we're on time to class. Okay? I'm thinking pretty soon every bell work is going to be worth points in here, because now we're getting used to doing them. We're getting most of these correct, actually. So we're going to start making points attached to it. So if you're coming late and you're not getting the points, you're losing points just by not being here and talking when you could be working. Okay.
Points for done or just points for correctness?
Points for correctness. And it'll be soon. All right, probably after this next test. Just to make a little more importance on this, that you're not coming here and talking. It would have been fine, no points, but people are wasting time and not getting it right, and I can tell why, because you waste 3 minutes of time and then you quickly do it as I say it's due. All right, so hopefully if I attach some points, we spend more time on it. All right, questions on the homework? Sabrina.
For number, number 23.
Number 23. Evan is 150. Or Aiden, sorry. I was the wrong person. Number 23? So number 23, we had to draw it. And I think 23 and 22 are about as hard as I can make these problems. And I wouldn't put one on the test that you have to draw and then say what you had to prove. And then it's just a really good way. Adios. It's a really good way to see if you kind of understand how things are happening. But don't expect one of these to be on the test in case you're really stressed out about it, because they are tough. I'll just take a picture of my picture and we will talk about it. All right, it says in an isosceles triangle, so the first thing I drew was an isosceles triangle. And so that side is congruent to that side. If a segment is drawn from the vertex of the angle between the congruent sides, so this is the vertex between the congruent side, right? The angle between the congruent sides, that's why I put that there. And it goes to the midpoint of the opposite side. So it goes straight down to a midpoint. But what it means to be a midpoint is that is congruent to that, right? But my drawing is just this to the midpoint. And so my given is, hey, I have an isosceles triangle where this side is congruent to that side, and M is the midpoint. I need to prove, however you label this, that this triangle is the same as this triangle. Well, I already know this side is congruent to that side. I know this is congruent to that because it's a midpoint. And the only thing I have to actually show is that through the reflexive property, this is congruent to this to make it side, side, side. So per the given, these two sides are congruent. Per the given, M is the midpoint. Because it's the midpoint, AM is congruent to MC. And then we just have to use the reflexive property to say MB equals MB. And then it's just side, side, side. Proves the triangle. Yes?
Wait, after you do like a certain amount of steps, how do you know when to use the reflexive property?
When to use it?
Yeah.
You could use it at the very first step if you really wanted to. There's no order it has to be done in, right? I don't have to say when I use the reflexive property. I just at some point have to say this line is congruent to that line so I can have side, side, side. So if you had, did you have like reflexive property maybe up here or something? Maybe higher? Yeah, that's okay. You could have said this is my given. My second step could have been reflexive, and then my next step could be the next given. All right, doesn't matter where I put it as long as it's in there. Yes?
I don't know if mine is like a couple, I got to SSS and like the given or reflexive property, but I did BM bisects angle ABC as a given, and then I did angle ABM is congruent to angle CBM, and then I did definition of bisector, and then I got into given reflexive property at SSS.
Why would you prove two angles are congruent if you're using side, side, side?
Right? I don't know.
You could have used it. You absolutely could have. So you proved that this was congruent to that. But we don't know that because it doesn't say it's bisecting. You came up with bisecting.
Oh, midpoint.
Nowhere, yeah, it just says midpoint. The one before it said bisecting, and the one we did in our notes we used bisecting. This one was midpoint, so we had to use side. So you saw it had to be side, 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 but you came up with a brand new fact about it bisecting, and it's not.
So it's midpoint.
It does turn out to be bisecting, but we don't know that. It's not given to us. Yeah.
The third step in number 17.
The third step in number 17. I'm going to hold on just for 1 second on this. Does this make sense then, all of these steps? This is about the only way to do it. You could just change the order, like Akshay said. You can change the order of stuff, but generally each of these things need to be in there. All right, 17. You said 17, the third step?
Oh yeah.
I believe I included a picture, right? Because I drew it and I'm just like, I should just give it to you. I gave you this picture, right? Minus all the ticks and stuff. And so if I give you fill in the blanks, you should really think about how to prove it on your own. Okay? So I'm looking at RS is perpendicular to ST. RS is perpendicular to ST. So we just have, that's a right angle. That's a right angle. We have V is the midpoint, so this is that, and we have vertical angles. So that's the bulk of the entire proof, is that this is 90 degrees, and that's 90 degrees, so they're congruent, it's vertical. So let's just see here. So they said this, I bet you got the given right. We have measure of angle S equals 90 and measure of angle T equals 90. That's definition of perpendicular lines. And then C says S is congruent to T. That is definition of congruent. Did you have something else written down there?
That's substitution.
Substitution works also.
Oh.
Yep. It's it's one of those, I think Amber, you had this question. Someone had this question in class. It was just such an easy step to go from here to here that it was hard to say why it was true. And I just used definition of congruent angles because we know they're both equal to 90, so they must. But substitution is a great thing to use too. All right, other questions? No? Okay, then we'll go into today's lesson. Today's lesson is more proofs. But I want to show you how to make these easier on yourself. All right? Because I think a lot of times we just start writing the proof, and those of us that are good at it might be able to just write the proof right away. Other of us need to think through it before we write the proof. We'll be more successful writing it. So this one says, this first proof says, given AB and CD bisect each other at M, prove that triangle AMD equals, all I'm going to say is the other triangle for right now. All right? I'm not even worried about which triangle it is. I'm just going to say the other triangle. Let me get this up so I write the same stuff. So let's look at the given. The given says AB and CD bisect each other at M. What information can I get from the given? Yes?
That means that AB is, like, CD bisects AB at the middle of it, so we know AM and MB are congruent.
Mm-hmm.
And then if it also bisects CD, we know CM and MD are congruent.
Oh, that is just perfect. So what I'm going to do is under my plan, and this can get you points if you don't know how to fill out the proof, is just say from the given, right? From the given, I know a bunch of information. I know that AM is congruent to MB, and I also know that DM is congruent to MC. So without even doing the proof, I know that so far. I know from the given, I know those two bits of information. All right, so I have side, 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 side. I either need side, 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 or side, angle, side. What could I do to either get this side or this angle, Stephen?
To get that angle, it's vertical angles.
Vertical angles. So do we all see that this is a vertical angle? These two things are vertical angles. So that means all we're going to use is vertical angles. That gets me that angle, what is that, AMD? Ooh, I just went to M. Is congruent to CMB. Yes?
Isn't there also, like, a theorem that says, like, if you know the two sides are congruent, then you know the third side?
No. There's one that says if we know two of the angles are congruent, we know the third angle.
Oh, okay.
Sides isn't true, because picture a triangle that looks like this. I don't change the length of the side, but won't my third side be a lot longer?
Oh.
Can you picture that? Yeah. Amber.
So if I said AMD is congruent to BMC, that's the same thing?
Absolutely.
As long as I've got M in the middle?
Yep. That's the nice thing about angles, because we only care about the vertex. Triangles are different.
Yeah.
All right, so we have our given gives us two sides. Vertical angles gets us this angle. And we now know, I'm not going to write down what triangle it is. I'm just going to say I know I have side, angle, side. Do we see the side, angle, sides? That's the entire proof right there. We just did an entire proof without writing anything in a two column. That way, for people that are struggling with the proofs, follow these steps and you'll know exactly what to write. So my given gets me both this information. So the first thing I'm going to write down is the given. So our first step is AB and CD. I'm just going to put bisect. Officially, you got to say bisect each other, so we know there, but bisect tells me they do bisect each other. So the first thing is given. Well, we said from that given, we know that AM is congruent to MB, and we know that DM is congruent to C. And that's what it means to bisect. That's just what Grace said. That's what it means to bisect. Definition of bisecting. However you want to put that. I am not. You know I'm not overly concerned about your reasons as long as it makes sense in the not definition of parallel lines, I think. So definition of, just put bisect. A period for bisecting. Well, now even if I'm lost, I already wrote down what to do next. I said use vertical angles to say that. So my third step is that angle AMD is congruent to angle CMD. And that's vertical angles. I already have that down, so that's what helps me. Yeah.
Is it CMD or CMB?
I have CMB. It should be CMB, right? You are correct. And that's vertical angles. So we know our fourth step. I wrote down that it's going to be side angle side proves that they're congruent triangles. Now I just got to figure out which triangles are congruent. Yeah?
AMD and BMC.
It's congruent to, say that one more time?
BMC.
BMC, let's check that. So you're telling me A and B, those look pretty right. And to go from A to M, I go across the one with 1. B to M, I go across 1. M to D, I go across 2. M to C, I go across, yep, 100% correct. Side angle, side. I didn't get lost while doing my proof because I wrote a nice little outline here of what to do. All right, that's what I want us to do in these proofs. Whether you do this in your head or you actually write it out, you should be constantly thinking about what makes it true, what is my end result, and show me the steps on how to do that. Make sure you show me why each side is equal to the other side and why each angle is congruent to the other angle. Don't skip stuff because you know it's true. All right, I'm going to leave this up just like this because I want us to look at down at this other thing. Notice our next one starts out the exact same way. It says that A, B, and C, D bisect each other and has the exact same drawing. It wants us to prove something else. It wants us to prove that AD is parallel to BC. Do you see that subtle difference? Well, to prove that two lines are parallel, I need to show that either two alternate interior angles are congruent or two corresponding angles are congruent, or two same side. Typically with triangles, it's always going to be alternate interior. Like 90% of the time, sometimes it's corresponding. It is almost never same side equals 180, all right? So when we're proving triangles, it's usually alternate interior, sometimes it's corresponding, and those are the only two I'm looking for. So I'm trying to prove that AD is parallel to BC. Yes?
So can you just, since we know that like triangle A and B is congruent to BMC, we know that like A and B, which are alternate interior angles, are congruent. So do that.
That's our whole proof. Our whole proof for this second one is to prove that the triangles are congruent. Well, we already did that. We already did that, so what we're going to basically do is we're going to snag off this guy and throw it down here. All right, we're going to throw down that fourth step saying, hey, I already did that, I'm not going to do it again. And then we're just going to say either angle A and angle B are congruent because of corresponding parts of congruent triangles are congruent, or CPCTC. And once I say these two things are congruent, then I can say they're parallel because alternate interior angles are congruent, so they must be parallel. So that's exactly what we're going to do. So our plan is basically, we don't even do a plan for this one because we did most of it anyway. So 4 is basically saying that my triangles are congruent. I forget which triangle. Did we say AMD? Was it triangle AMD?
Triangle AMD is congruent to BMC.
Is congruent to B. Yeah, that's BCM. BMC. And that last step was side, angle, side. So step number 5 is just like Ray said, just go ahead and say that angle A is congruent to angle B, and that is because CP, CTC, or KPKTK, or corresponding parts of congruent triangles are congruent. I would stick with KPKTK. It rolls off the tongue nicely. KPKTK. Just fluid.
It does for you, yeah.
All right.
Sorry.
So my 6th step is my final step. It is that AD is parallel to BC.
Oh, that's it? Wait, don't we need to have 2 of them though?
Nope. As long as one pair of alternate interior angles are congruent, they're parallel. So alternate interior angles.
Wait, so you can't use alternate interior angles for 5? That is.
Hold on one second. There's lots of people talking, so I can't fully hear you.
For 5, can you do alternate interior angles, and then just for 6, you use like the actual, just say alternate interior angles?
No. The only time you can use alternate interior angles are congruent is if you know they're parallel. If I'm proving them parallel, we need to prove they're congruent and then say they're alternate interior angles that are congruent. So this one has to be KPKTK. That's why we took the time to prove these triangles were congruent. These are the longest proofs you'll have to do, the ones that are you're proving something's parallel. Most of these you're just proving that 2 segments or 2 angles are congruent. So you prove the triangles are congruent, and then you just say, hey, by the way, these segments are congruent too because of KPKTK. That was a good one. I said that real quick and nice like. All right, does that make sense how we can go there? All right, that's all we're going to do for the next couple of proofs. All right, so the next one says PR bisects angle QPS. So once again, I'm going to come up with a plan. All right, I'm going to do my plan. And my plan always starts with my given. What do I know based upon my given? So the first one says PR bisects QPS. Ooh. Why do I care about that? Yeah.
QP is equal to PS.
Close, right? It bisects. So it has to do with the angle, right? The angles are congruent or equal. Yeah. So because PR bisects this angle, QPR is congruent to RPS. So I'm not only going to draw that in the picture, I'm also going to write it down. Yeah.
May I share my pencil?
Yeah. So angle QPR is congruent to angle RPS. Should probably write that down. Follow along. Oh, you were telling me the next statement. You were telling me the next statement, right? That PQ is equal to PS.
Oh, I didn't even know that.
Yeah. Do I need to break this any? Do I have to do anything to this? This tells me exactly what I need to know, and that is that PQ is congruent to. So if it's just straight up important information, we just leave it as is. So that tells me PQ, and I'll draw it on there, is congruent to PS. So now I have side angle. How do I know this side is congruent between the 2 triangles? Reflexive property. So in fact, the only thing I have to do now is just reflexive. Tells me that PR is congruent to PR. And I'll have side angle side. So side angle side will show me my 2 triangles are congruent. Is that what I ultimately want to do? Prove the 2 triangles are congruent? Is that my final step? No, I need to prove that angle Q is congruent to angle S. So my last step is just is CP, CT, C. So I prove the triangles are congruent, and then I use KPKTK to say that these two things are congruent. This is my entire proof right here. This will get you a ton of points if you have no idea how to write the proof afterwards. Okay, because I see that you got your angle, you got your side, you got your other side. And the nice thing about this is you don't get lost while writing your proof, because your proof is just your given. Maybe just your first given statement, and that is that PR, that says RR, PR, I usually just do a segment, not the whole line, bisects,
Oh, to write it out?
angle, yeah. Unless you just want most of the points. Is a given. Well, when you get good at this, you don't have to do this. You can do a lot of it in your head. Our second step is expanding on that, and that is that QPR is congruent to RPS. Our third step boils down to just PQ is congruent to PR, or PS, I should say. So PQ is congruent to PS. Maybe I should put the reasons down, huh? Definition of bisector. My third one is just the given. And I'm done with the given. Now I go to reflexive. Reflexive shows me that PR is congruent to PR. That is reflexive. My fifth step is just going to be that side angle side. And I just have to name the two triangles that are congruent. Can someone name the two triangles? It doesn't matter what order you do it in, as long as you, Evan, you want to give it a shot?
QPR,
Slow it. Okay, so it's Q, P, R.
and then RPS. Or, no, PR. I'm sorry, SPR.
It's going to be SPR,
So it doesn't matter, like, during the triangle?
which you just got to make sure whatever one you pick first matches the second one, right? So he picked Q, P, R. So Q went to P, and then he has S going to P, yep, and then P to R. Doesn't matter. If they don't tell you which one to start with, just pick any triangle for the top one, and then make sure the second one follows it. I kind of do what Evan does a lot of times. I pick the ones that I know are going to match up easily. And this goes along the long way, so this one's going down the long one. I pick what's going to make it easier for me to write it. All right, then my step 6 is just the fact that angle Q is congruent to angle S, and that is Kapukataka. Because we proved the two triangles are congruent, so that means every part of the two triangles is congruent. So that way I can tell you the Q is congruent to S because the two triangles are congruent. That's what CPCTC is. Do you understand why we're using CPCTC on that one? Are we confused at all? Okay. No, okay. I just saw a no and I'm like, no, you don't get it? Or okay, good. All right, please ask questions now, because otherwise your homework's really hard if you don't understand that. So the goal of almost all of these is to prove two triangles are congruent, prove two parts of those triangles are congruent using CPCTC, and possibly using that fact to show it's parallel. All right, the parallel one is the longest one because you have to show it's, and then you have to show it's parallel. All right, let's do one more together. This one, maybe I won't do the plan. Maybe I'll just write the given down and draw the picture along with it. So my first given is WX is congruent to ZW. So WX is congruent to Z. Wait. No. I was trying to remember what it said. So it's WX and YZ. That makes way more sense. All right, so let's make some marks on there. WX, YZ. It also tells me that ZW is congruent to XY. ZW is congruent to XY. So ZW is XY, and that is my given. Yeah, Sabrina.
So what I kind of realized about proofs is a lot of them kind of look very, very similar. So is it basically like the same exact format, just with different numbers?
It really is. Because all of these we're looking for side, 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 angle, side, or angle, side, angle, right? So everything you're just trying to show us that you can figure out those things. So each proof kind of follows the same thing. Take the given, figure out what you can get from that, find that third side or angle, and then show the two triangles are congruent, and then do stuff after it. That's how all these are laid out. So this one, in fact, is prove the two triangles are congruent, right? Wx is equal to zy, so we're going to have to prove alternate interior angles are congruent to show they're parallel. So let's take care of the triangles first, proving they're congruent. So I have side, side, so our last side is going to be reflexive, right? Is that what you're going to say, Hannah? Yep. Our next step is just to get the third side, which would be that zx is congruent to zx, that is reflexive. And now I can go ahead and say my two triangles are congruent because I do have side, side, side. So however you name it, I don't care. Just make sure it's correct. I'm going to name this one, let's go WZX. That's going to be congruent to, I know W matches with Y. And W went down 2, so Y is going to go down 2, so it's going to be YXZ. And that is side, side, side. Here's where it gets a little tricky. And here's where you might want to take colored pencils or in your head, draw it out, or however you want to do it. We are trying to prove that X, WX, so I'm going to color that in, and ZY are parallel. So if I prove that 4 and 3 are congruent, it doesn't work. You have to pick 1 and 2 because it's the only one that has a transversal that connects the two of them. Do you see that transversal connecting both of them? So you have to show that 3 and, I already covered it up, 4. 3 and 4 are congruent. That's the only way we can do it. But we can say that angle 3 and angle 4 are congruent because of, why can I do that again? Ooh. What's my reason for I can say they're congruent? Let me write it down first. Angle 4 is congruent to, did I say angle 3? Nope, I said angle. No, it's 1 and 2. Sorry, I can't see it. 1 is congruent to 2. And why can I say that, Stephen?
Wait.
Yep.
Yeah.
C, yep. Corresponding parts of congruent triangles are congruent. CP, CTC, or KPKTK. We can't say it's because alternate interior, because the only time you can say alternate interior angles are congruent is if we know they're parallel. Do we know they're parallel yet? No, we're trying to prove they're parallel. That was what Grace got stuck on. If you're ever using alternate interior angles twice, it means that one of them isn't right, probably. So our fifth step is that they're parallel, and that is because alternate interior angles. So WX is parallel to ZY. This one is our alternate interior angles. Kapakatika? It's really fun to say. All right, so be careful on these because alternate interior angles are going to mess with us. Sometimes they'll say two lines are parallel. Then I can say alternate interior angles are congruent. However, if I'm proving something's parallel, I have to prove they're congruent using CP/CTC to then say they're parallel. All right? Do you want me to say that again? Or did that make sense? I said sometimes they'll give you parallel lines, and then you could say alternate interior angles are congruent. But if you're proving parallel lines, you have to use CP/CTC to say that your alternate interior angles are congruent. All right? Let's go ahead and get started on the homework. I'm going to walk around and check your homework.